Let us have the following examples. So it says here, find the divergence and the curl of the vector field. So this is the given vector field. F of x, y, z equals x squared yi plus 2y cubed zj plus 3zk. Solving now for the divergence and curl of the vector field, starting with divergence. So we have here the formula. So the formula we have here is div f that represents divergence of the vector field is equal to partial derivative of the function with respect to x plus the partial derivative of the function g with respect to y plus the partial derivative of the function h with respect to z. So in your given vector field, so this will be your function f, your vector I component. Then the second term, which is the, or second component, which is the j vector, we have this as g function. Then lastly, the h function is 3zk. So we go now in finding the partial derivative of these functions f, g, and h with respect to the independent variables indicated in the formula. So that we have here now the partial derivative of f with respect to x. So we have it as in this manner, partial derivative of the function with respect to x is equal to, so what is your constant here? It is y. You may also rather include I. Then getting the derivative of x squared, that is 2x. Or simply, we can write this as 2x yi. But since this is a divergent of the vector field, so we may not include I. So we can write it as 2xy. Then we have the partial derivative of the function f with respect to g, or rather, partial derivative of the function g with respect to y. So we have here now, this is your g function, copy your constant, that is 2z. So I will not include anymore the j. Then the derivative of y cubed is 3y squared. So when you simplify this, we have it as 2 times 3 is 6. Then we have y squared z. Then lastly, we're going to get the partial derivative of the function h with respect to z. So since we have 3zk, or just simply 3z, so this will just be 3. So collecting now this partial derivative, so we write in this manner, div f is equal to, you have 2xy, because that is your partial f with respect to x, then plus partial g with respect to y, which is 6y squared. Say, then we have partial h with respect to z is just simply 3. So this is our answer for the divergence of your vector field. As we can see here, this is also the answer. Then let us now compute for the curl of the vector field. For the curl of the vector field, we have the following formula. These are the two formulas. So I would suggest that you will use the matrix rather than this formula. which is of course also obtained from here. So with that, let us use the formula of this curl f of your vector field by defining the components in a matrix form. So we have the first component to be ijk. Then we have in the second row, we have the following partial derivative symbols. And in the third row, we have the components of your vector field f. So we have it as the first element here is your function f, then the second element is your function g, and the third element is your function h. So with that, we can just copy now the first two columns, then apply the basket method. So we now have I, then we have partial derivative with respect to x, then we have x squared y. Then we have here j. Then we have partial derivative with respect to y. Then we have 2y cubed z. So using the basket method, so we will have the diagonal multiplication starting from the upper right, or rather upper left. So multiply now these elements diagonally. So that means we have here the partial derivative of the function 3z with respect to y times I. So we have here now, so let me just write it here. Curl of f is equal to partial derivative of the function 3z with respect to y times I. Then we have here the partial derivative of the function x squared y with respect to z. So we have partial derivative of the function x squared y with respect to z. Then we write j. Then plus we have here partial derivative of the function 2y cubed z all over partial derivative with respect to x times k. Then we now perform the other multiplication. So this is minus. So it's like finding now the determinant of this matrix. So starting here, this is like in your linear algebra. So starting from the bottom left, we have the partial derivative of the function x squared y with respect to y, then times k. So we write it as partial derivative of the function x squared y with respect to y times k. Then you have here partial derivative of the function 2y cubed z with respect to z, then times I. Then we have plus partial derivative of the function 3z with respect to x times j. If you're going to look here, do we have the same answer? So we have here partial derivative of 3z with respect to y times I. So this is using the formula here. Then we have, so you have here the minus sign here. So we have here I also, that is now partial derivative of 2y cubed z with respect to z. So we combine those common vector psi. Then we have now plus this one, partial derivative of x squared y with respect to z times j. Then we're going to combine it with here. That's minus partial derivative of the function 3z with respect to x, j. Then finally, you have this combined with this, so they are equal. It's just that I, j, k here are factored out. So that, let's now get the partial derivative of the function. So this will be 0. Why? Because this is with respect to y. Because z will be considered as constant. So this is 0, while here, so this is also 0 because x squared y, so this is with respect to z. So this is also 0j. So again, 0i plus 0j. Here we have also 0 because we have the independent variable here is x, so we have here y cubed z. So that will also be 0. So I'll just write here 0, 0, 0. Then you have minus. So here we have to take the partial derivative of the function x squared y with respect to y. So copy your constant x squared. Then derivative of your y equals 1, then times k. Then here we're going to get the partial derivative of 2y cubed z with respect to z. So we can copy the constant, so positive 2y cubed. Then the derivative of z with respect to z is equal to 1 times I. So we have here. Then lastly, partial derivative of the function 3z with respect to x. So this is constant, so the derivative is 0. So we write here 0. So therefore, we now have to simplify, that's negative. So let's start first with the I vector, so that is negative 2y cubed I minus x squared k. So we have the same answer here. So this is how we compute for the divergence and curl of a vector field.